For these next two examples, I want to show you how we would graph tangent with transformations, because all you've seen so far is the parent function of tangent, which we will refer to a couple of times. When we're graphing tangent, it's actually pretty similar to what we did for sine and cosine. So the general equation is y equals a tangent b x minus h plus k. The first thing you want to do is graph the function without transformations. So where only a and b are impacting the graph. So if I'm looking at example 1, I'm only going to graph y equals 2 tangent x. I'm going to save the negative, which would cause a reflection, and the h value, which would cause it to move left, for my second step. A is going to be 2, and b, the number in front of x, or in front of the parentheses, is 1. Now remember, the period for tangent is pi over the absolute value of b. So this is a difference between tangent and sine and cosine. So pi over 1 would give me a period of just pi. Now we can set the scale just like how we did with sine, cosine, tangent. So you can put 4 tally marks and label it 1/4, 1/2, 3/4, and the full period length. So the full period length is pi, which means 1/4 of pi is pi over 4, 1/2 of pi is pi over 2, and 3/4 of pi is 3 pi over 4. Now the parent function, we saw that one full cycle was pi, but when I'm looking at the origin, one cycle right here, half of the graph was on the right-hand side and half of it was on the left-hand side. So that means that I'm going to have an asymptote here at half of the period length, and then I'm going to have an asymptote on the left-hand side at half of the period length. So this is negative pi over 2 and negative pi over 4. The pattern for tangent is that the first cycle starts with the origin, and then on the right-hand side, we're going to go right 1 tally mark, up whatever the a value was. The a value was 2, so if you use a scale of 1/2, you would go up 4 units. If you use a scale of 1, you would go up 2 units. So I'm just going to use a scale of 1/2 just to be consistent. That's what I normally like to do. So I would move right 1, up 2, and then on the left-hand side, I'm going to move down whatever a was. So I'm going to move left 1, down 2. That's just one cycle of tangent. If I wanted to draw another cycle, I just would keep repeating the pattern. So you can extend whatever side you want. The pattern is asymptote, coordinate below, x-intercept, coordinate above, asymptote. So let's do that again. Asymptote, coordinate below, so at -2, x-intercept, coordinate above, asymptote. This pattern will continue forever. So you can keep going and going and going. This is the graph without any transformations. Now we're going to do the transformations. The first transformation I'm going to do is a reflection. I like to do the reflection first and then move it. So I'm going to show that in red. A reflection, asymptotes stay the same, intercepts will stay the same, but the coordinates are going to flip. So instead of being down 2, we're going to move it up 2. Instead of up 2, we're going to move down 2. So we're basically reflecting about the x-axis, or it's going to be a mirror of what we currently had. Now, just so you know, these asymptotes are still the same. They're still there. It's just the reflection didn't impact it at all. Now what we're going to do, and I'm going to do this in green, is I'm going to move it left pi over 4 because I had an h value. So what you're going to do is you're going to take each coordinate and asymptote and move it left pi over 4. So pi over 4 was one tally mark. So I'm moving this asymptote left pi over 4, this coordinate left, and then the next two, this asymptote will be moved left, coordinates move left, and then our last asymptote. Connect your points with a S-shaped curve. So my green graph is what tangent will now look like after both transformations have been applied. Let's take a look at example 2. The only way we're going to get good at this is if we keep practicing. So we are going to spend 2 days on this just for you to get the hang of it. Okay, so the first thing we want to do, like I mentioned before, is graph it without any transformations. So we're going to do y equals tangent x. This is the parent function once again. So for tangent, we look at A, which is the amplitude, and that impacts the coordinates that we have, how we move left and right, like whether or not we go up or down however many units. And then B impacts the period, just like how it did with sine and cosine. But it is different because the period is pi over the absolute value of B. So here it's going to be pi over the absolute value of 1, which is 1, so it just is pi over 1 or pi. We could set it up the same way just to keep in that habit of 1/4, 1/2, 3/4. But instead of just doing the right-hand side, I'm also going to do the left-hand side. It's just going to be the negative values of what we just labeled. So if this is 1 pi over 4, this is negative 1 pi over 4. If this is pi over 2, this is negative pi over 2. 3 pi over 4 becomes negative 3 pi over 4 over here. And then pi and negative pi. So we're using a scale of pi over 4 throughout the entire x-axis. And then I'm going to use a scale of 1/2 for my y-axis, just to stay consistent. Now, the period is pi, but the pattern is asymptote, coordinate, x-intercept, coordinate, asymptote. I like to draw my cycle, my first cycle, as the cycle that passes through the origin. That just makes it easier for me. So that means the right-hand side will go up whatever A is. So I'm going to go up 1 unit. And then the second tally mark would be where the asymptote falls. Again, I'm just following the pattern. X-intercept, coordinate, asymptote. And then on the left-hand side, I have my x-intercept coordinate, but this time I'm going down whatever A was, and then asymptote. So you should have something that looks like this. Now last time I repeated the pattern and did it on the left side, or excuse me, the right side, but we could also do it on the left side, so I'll show that to you as well. Just keep repeating the pattern. Here's an asymptote, coordinate, so since it's on the left, see how by this asymptote, I moved up, so it goes here, x-intercept, and then coordinate, asymptote. And you can repeat that pattern forever. Now, transformations is the second step. For this example, I'm going to be moving it right pi over 2 and down 2. If there would have been a reflection, I would have wanted to do that first, but there's not. So I'm going to take each coordinate and asymptote and move it the way it's instructing me to. So if I'm going to move right pi over 2 units, that's 2 tally marks. You see how it's pi over 4, pi over 2? So 2 tally marks to the right, and then 2 down. So that would be 4 units. Okay, so I'm going to start with this asymptote. I'm going to move it right pi over 2, so that's 2 tally marks, and then down 2. But moving it up or down doesn't really impact the asymptote. Moving it left or right is what's visible. Now this coordinate right here, I'm going to move it right 2 units, down. Next coordinate right, down. Next coordinate right, down. The asymptote. Originally it's at negative pi over 2, but now when I move it right, it goes to 0. And then when I move it down to, you can't really tell because it's already a vertical asymptote. Move the coordinates here, right 2, down. Continue with your other coordinates. Oops, right here. And then my last asymptote. Remember, your tangent function can approach the asymptotes but never touch it, so make sure you draw it in a way that reflects that behavior. And the red is my final graph. On the homework, I want you to cross off in the directions where it says domain and range. Number 1, you're graphing it without any transformations because there's no h and k. Number 2, I just want to remind you, once you graph tangent without any transformations, I then recommend you do the reflection, so do that in a different color, and after the reflection, move it left, right, up, or down, just like what we did with sine and cosine. Okay, careful with the a value here on number 3. And then careful with how you label the period on number 4. Really, it's just going to take practice, and we're going to spend 2 days on it. So do your best on this homework assignment. I'm going to post the answer key when I'm done, and if you struggle with this, remember that there's a learning center on Thursday, so you're welcome to come in and ask questions.